For this exercise, we will start our first program using Dev C++ as our platform to write source code. We will do an example in C and C++. Okay, so there will be two examples to show how to use this IDE right here. Okay, we have another video that showed how we installed Dev C++. Okay. To be organized, I'm going to create a directory where I am going to store the files that we create. So I'm just going to right mouse click here and go to New, create a folder, and call it My Code if you want, whatever you want to call it. And then under that, we may create a couple directories, one for C code and one for C++ code. Okay, so we can go ahead and do one, new, C++ code. Okay, and we're going to have another one for just C code. Okay, so these are optional, but at least it allows you to organize your work and go back to your exercises, find where you left off any of these files so you're not chasing them throughout your computer. You definitely don't want to store stuff on the desktop raw without putting them in a directory. It's just going to get messy. Okay, so now let's get started. Let's start with a C code, filling in the C code directory with an actual C program. So let me go ahead and double click on Dev C++. Okay, here you go. All right, so I have it on full screen on my virtual machine. And while I'm in here, I am going to say File, New, Source File. Okay, this is not a project. In another example, we'll do projects. So for now, just basically a source file. This will be a C program. Okay, just to quickly see how it works, how it compiles, and what does it do after it compiles. How do we obtain the executable and run it? We're going to go through the cycle of creating at least one function or one job that will do this for us. Okay, all your program, either be it in C or C++, will have a function called main. All right, so if this is a C program, at minimum, it will have this function, main. It's a job, and curly brace, curly brace. I have too many curly braces. Let me just kill one of them. Here you go. That is a function. Basically, it means this is the name of the function. Here, between the parentheses, it will take what we call parameters. Right now, it doesn't have any. This curly brace is the beginning of the function, and the other curly brace is the end of that function. So basically, your code will be between these two curly braces. Okay. So for now, I am going to save this program as a C program. So this is where the magic happens. So you go ahead and say File, Save As, and this is where you get a chance to either create a C++ program or a C program. In our case, we want a C program. It's going to be on the desktop under My Code, under C code. Remember that? And I'm going to change the Save As type to a C program. So notice here's C source file. Do that first before you name your file. And we're going to call this one test1, right? Okay. So save. Now notice now the ear here on the tab says test1.c. Okay. So let's see what is the impact of doing that right here. So if we go to C code, notice I have a source file, and that's what the operating system sees it as. And it's a C source file. Cool. What can we do with it? Well, let's go back to Dev C++ right here. Okay. Now that we've saved it, can we actually do something with it? Can we run it? Well, let's attempt that. So you can go to execute. First, you need to compile it. Compiling it is going to change whatever you're seeing here in English, right? This is almost English, right? Or what we call a high-level language, closer to human language, into something closer to machine language, right? So that means it will create for you another file for the consumption of your computer or your operating system to run it. Because you can't just run this, right? Your computer does not understand English, so you'll have to translate. And that's what the compiling part is. So if I hit compile, okay, and I look down here and it says, great, compile results, 0 error, 0 warning, so it compiled. And it created for me a test1.exe for me, an executable. That is what the computer would be able to run. Well, let's prove that. So let's go to the directory we had here. And sure enough, now we have two files. Notice we had our C source file, and now we have an actual application. Now, what does it do? You can run it. It really, there's, in the job description here, there's nothing, so it's not going to do anything. So let's go ahead and run it. So notice compile was above it. Let's go ahead and run it. And notice nothing happens. Really, what it allows you to do here is to show you the console. And notice it's blank. There's nothing. Just press any key to continue, and you're done. So it shows you that the process exited after this many seconds. So what happens is it ran the .exe file. That takes time to execute. Okay? So the computer or the operating system create what we call a process. Okay? And a process is born and then it dies. It's born the moment you run the application. It dies when the application ends. And that's what happened. This is the lifespan of that process. Okay? And then it returned a value of 1 back to the operating system. It's basically a signal back to the operating system. How did this program terminate? Okay? So press any key to continue. Right. So now we want to communicate with the operating system. Maybe we could tell it to return a 0. Let's go ahead and do a return 0. So that means when you're done, this is what we want you to do. Now, any changes you do to a program, you're going to have to recompile and then run it again. So compile again. Okay, so 0 errors, 0 warnings. Let's see when we run this, what happens. And sure enough, that this time, notice I sent the message back to the operating system that we terminated properly with a signal of 0. So it's basically saying that, yes, we've reached the end of the program. The operating system captured the 0 as a flag that I said return 0 back to the operating system. And that's indeed what happened. Now notice the time here got a little longer, right? It was a lot shorter with that statement. So within the process, you're going to have to execute lines of code. And we only have one line of code under main, return 0. So it takes a little more time for the processor to run that. Okay, good. So let's see what else we can do with this program. Okay, let's say we want to print something to the screen. Right, so your typical hello world. Now, for a C program to do that, you're going to have to tell it how to print by invoking another function called printf, right? So printf, right, will print to the screen. However, where does it know, or how does it know how to work it or execute that particular function? Unless I create it myself. If not, then there must be a standard function that I could use from a standard library that I could extract. So first thing we're going to do is actually go ahead and include a library that will allow me to use that printf function. So let's go ahead and do that. So the include statement, include, and that would be stdio, standard input output .h. It's a header file, right? So it's a separate file that we are now linking to this program. Okay, so where would that file be stored? Well, when you installed your Dev C++, for example, it installed a mingwin.exe, which allows you to use C and C++ within your computer. And it included also the library files and the path as to where they are. So in our case, we don't care specifically where the path is. stdio.h is a relative path that will go straight to that directory where these helpers are and bring it in for me. So now, let's go ahead and do a printf function. Notice that it's a function. Now notice every line I execute has to have a semicolon. I didn't type printf properly. Here you go. Now, if I do just printf like this and compile, there's nothing really going on with that function. As you can see, I get an error because printf requires that you put in, okay, what we call an argument. What is it you want to print? Okay, well, if I put quotes, that's an argument. I want to print a string out to the screen. Hello, hello there. Now that is an argument that it can take, right? So notice the error at the bottom. Too few arguments to function printf. Well, guess what? I gave it an argument. Go ahead and print this string out to the screen. All right, well, let's see if that works. So compile again. Okay, so 0 errors, 0 warnings. Let's go ahead and run it and see what happened this time. Okay, so hello there. Not hell there. Now, that would be bad form, right? So let's put an O there, all right? So, yeah, I know. So we're all under COVID-19, so this is... Oh, by the way, you could do a compile run. Both of these two things can be done at once. So compile run. There you go. There, with problem fixed. Hello there. Okay? Cool. So it returned the 0 as expected. It took some time to execute. Okay? And what it did, when it executed, it printed here to the console. Okay? So what you're seeing here is basically a report on how the program ran. Okay. Can we do more than just hello there? Yeah, sure. Notice that you can create new lines with new instructions. So you repeat that same function, printf, and do something else. This is our first C program. And indeed, now remember, we should put a semicolon at the end. Now, I omitted one particular thing here, and we're going to see what the problem is. Notice I have 2 lines of code, right? And I am going to compile and run. Watch what happens. Hello there. This is our first C program. Now, notice that just because you wrote the next instruction in another line does not mean on the console it will print it on the next line. Can we control that for clarity purposes, so the output looks neat, right? So yes, we can. We're going to use what we call escape characters. Escape characters are interpreted, so they're not going to be displayed. Okay? So the way to do it, you could do, for example, right here, maybe a /n. So a /n, so n is a character, but by putting a slash in front of it, this makes an escape character. So this gives us a chance to get a hard return. Give me a new line without displaying /n on the screen. So let's see how that works. Compile and run. And there you have it. Hello there. Notice there's a hard return right here. This is our first C program. Fantastic. So in the next video, we'll do the same example in C++.